So this video example is going to go over graphing a system of linear inequalities. And the big idea here before we move on is just connecting the word system with two or more inequalities at once. This video will only focus on two inequalities, but technically if we use the word system, it could be more. And again, we're trying to solve both of those inequalities at the same time. So find solutions to both of them. So this is just a quick little preview of what we're going to be doing. So we know already how to do just a single linear inequality. So up here, I have the inequality y is less than 2x plus 1. So we put in the borderline, which is a dotted line, and then we shaded in all the solutions over here. So the blue things are the solutions to this inequality. What I have prepared on the right side is just another inequality, y is less than or equal to negative x plus 4. And we did the same thing. We plotted the borderline, right? That borderline is a solid line this time because our original has a less than or equal to sign, and then we shaded in all the numbers that were solutions to that inequality. If you're unfamiliar with graphing one inequality in two variables, go back and check that out first. So if we're doing a system of inequalities, we know that when we're looking for a solution to a system, it's where we're looking for the points where it satisfies both inequalities. So if the blue satisfies this inequality, and the orange satisfies that inequality, where are the points that satisfy both? Well, that'd be where they overlap. These points right here are shaded blue and orange, which means they're solutions to the blue inequality, and they are solutions to the orange inequality. So we are looking for the overlap of those shaded regions. Again, they would be shaded on both graphs. So in other words, if we put them on the same graph, where would they overlap? So here's a quick list of steps that I would encourage you to write down and have on hand as we do the next examples. But just the general idea of how we're going to graph a system is we're going to be giving two inequalities. So inequality number 1, and then we'll also have a second inequality, number 2. What we'll have to do, and I'm specifically not using actual inequalities just to be general about it, but the first thing that we're going to have to do is we're going to have to graph that first borderline. Now we know that's just a single inequality, and we already know how to do that. So let's say we were to graph a borderline, and it looks something like this, and then we pick where to shade, and we realize we would shade down here. So we found the answers to the first inequality. Then what we're going to do is we're going to graph the second inequality. So we'd put that borderline down, and maybe it looks something like this, and then we would decide where to shade for that line. Once I've plotted both borderlines, all I'm going to ask myself is where are they both shaded in? And as I indicate here, where they're both shaded in, this is your solution region. So where do they overlap? Well, it's shaded blue and red right here. So this area I'm going to indicate as my solutions. So that's our general idea. So our first specific example, we are supposed to solve this system of linear inequalities. So the first step is to look at that first borderline and go ahead and make a graph of that. So this borderline is in slope-intercept form. The y-intercept is 0 and the slope is 1. So we're going to go ahead and we're going to plot that line. Now before we connect the dots, just like we did with a singular inequality, we need to make sure to connect it with the right type of line. Since there is an open circle, or excuse me, an open inequality symbol, just like open circles, this would be an open line, so it's a dashed line. Now I'm going to choose a point to test, so I'm going to test this point right here, which is the point 10, 0. So if I test that point, the y value of 0 is that less than 1 times my x value of 10 plus 0. So is 0 less than 10? That is true, so I know the solutions are on that side of the line. So I'm going to shade on this side of the red line. So I have all the answers that are solutions to this inequality. Now I'm going to move down and go graph the second inequality. So the first thing I would need to do is graph the borderline. This also is in slope-intercept form, so the y-intercept is 1, and the slope is -1. So we go ahead and we plot that borderline. And the same thing I did last time, I'm going to be very careful about connecting the dots. I'm going to go and look at the original inequality symbol, and since there's an equal to, I know that this is going to be a solid line. Now I'm going to choose another point to test, so I'm going to choose, doesn't matter what point I choose, I'm going to choose this point. So this is the point 0, 10. So if I test 0, 10, so this is the original inequality, y was greater than or equal to the opposite of my x value plus 1. So the number that I'm trying, the y value is 10, the x value is 0. So is 10 bigger than or equal to 1? That is true, which would mean that this point is a solution, so everything on this side of the line will be a solution. So where did I graph them both? In other words, where is it shaded green or blue and red? Well, that's all of these points here. So I'm going at the end to clearly indicate my solution region, because the things that are shaded in green, those are the solutions to the system. So just a quick follow-up to that. So I've just cleaned up my work a little bit. I have the original inequalities from the last screen, and then the graph that we produced. So one quick thing to check in on is how we can check our answers and use the graph to answer more. So let's say we were given the point negative 10. Well, let's do a different one. Let's start with the point negative 1, 9. I want to know if this is a solution to something. So if the point is a solution just to the red one, so let's find the point negative 1, 9. So negative 1, 9 is right there. Since negative 1, 9 is shaded in blue, that means it's going to be a solution to the blue inequality. Negative 1, 9, that point right here, is not shaded in red, so it is not a solution to the red inequality. If it's not a solution to both of them, it is not a solution to the system. We can check that algebraically. If we were to plug it into the system, the point negative 1, 9, it does not satisfy both original inequalities. 9 is not less than negative 1, so it's not a solution to the entire system. If we do something like the point 9, let's do 5, 2. So the point 5, 2 is right here. Now visually speaking, since it's shaded in green, we know it's a solution to the entire system. But if we look under the green, that point is shaded in red, and it is shaded in blue. So since it's shaded red, it's a solution to the red inequality. Since it's shaded in blue, it's a solution to the blue inequality. And since it was shaded in twice, we could just say it's a solution to the entire system. And of course, we could check that algebraically. Let's say we didn't have a picture. How could I know that the point 5, 2 is a solution to the system? Well, I just check both original inequalities. So if it satisfies the first one, so in other words, is y less than x, and does it satisfy the second one, is the y value bigger than or equal to the opposite of your x value plus 1. So I could just go ahead and plug in the numbers. So the y value is 2, the x value is 5, 2 is less than 5, so that's why I put a check mark there. If I look at the next one, the y value is 2. In the box, my x value is 5 plus 1, so is 2 greater than or equal to negative 4? That is also true, which is why I put a check mark in that box. And since I put a check mark in both boxes, meaning it satisfies both inequalities, it is a solution to the entire system. So another example here, we need to graph a system of inequalities, and we can see it's a system because we are given more than one, right? We have this inequality and this inequality, and we need to do them together. So one important thing here, when we're doing these inequalities, it's okay to use the x and the y-intercepts to make your borderline. So like here, if I was finding the x-intercept, that's where y is equal to 0. And I'm just going to imagine it's an equal to just for a second. Where is the x-intercept? Well, the x-intercept is negative 2. The y-intercept is when x equals 0, so that's when y equals 4. So for this type of problem, I can go ahead and just plot my x and my y-intercepts. Now with that x and y-intercept, I actually do have a slope that I can continue to use. So I'm just going to put that in like a yellow color really quick just so we can see it. But if I started at this point here, I went up 1, 2, 3, 4, and over 2. So I don't need to rewrite the equation to graph it. So I'm just going to go up 4 again, 1, 2, 3, 4, and over 2, and place another dot there. From this point here, go down to 4 and over 2. down 4, and over 2. Now when I connect this, notice how I'm connecting it with a dotted line at this point, because the original inequality was an open inequality, so I have an open line. Now just like before, I'm going to test a point. I always recommend trying to use 0, 0. That's just a really nice point to use because the math is really easy. So we're going to test 0, 0. So if I plug 0, 0 into the original equation, 0 is less than or equal to 4, so I'd have to shade that side in. So wherever 0, 0 is, that's the side that contains all the solutions. Now I have to go to the next one, and again with this next one, I can just graph it with the x and the y intercepts. So if y was equal to 0, I'd be looking when is 2x the same thing as 4, so the x-intercept is at the point 2, 0. The y-intercept is if x was equal to 0, so that's clearly the same point, 0, 4. So if I put 0, 4 and then 2, 0, now again I've established a slope. For this one I'll just use maybe like an orange color here. So for this slope I went over 2 and down 4. So if I need to plot a few more points, I'm going to go over 2 and down 4. Over 2, down 4. And I'm going to do a few in the other direction. And of course with this one too, I noticed that inequality symbol is an open inequality symbol, so I would use an open line. Now I'm going to again choose the point 0, 0 as my test point, because it's not on the line, it's on either side of the line. So if I test 0, 0 is 2 times 0 plus 0 greater than 4. And in this case it's not true. 0 is not bigger than 4. So I don't shade that side. I'm going to shade the other side. So now I'm looking on my graph for my final answer. Where did I shade both of them? So my final solutions I'm going to shade in green here, and those final solutions are where I shaded red and blue. So the final solution, which I'm indicating, are in green. The blue shading and the red shading is just my work, my actual answer, or any of the points that are shaded in green. So these are all of the xy pairs that would satisfy that system. So with this last system here, I was going to use it as a practice, but also kind of demonstrate one other way that maybe you'd want to show your work rather than doing all the shading. So here's my first inequality. I know that if there's only a y, this is simply a horizontal borderline. All right, I could think of it as 0x plus y is greater than or equal to -1. So that slope is 0. The y-intercept is -1. I am going to connect it with a solid line because of the equal to component. So here's my first inequality border. Now I'm going to test a point. I always like to test 0, 0 if I can. And since 0, 0 is not on the line, I can go ahead and test it. So all I need to do to test it is compare the y value. Is it bigger than -1? So that y value is 0, and this is true. So we are going to shade that side. Now this is where the shortcut can come in. So rather than shading, I'm just going to indicate above that line is where I would shade, because 0, 0 is above the line. So notice I'm just putting in these little arrows to indicate where I would have shaded. Now for the next inequality, I got to graph this borderline. Now this borderline is given in slope-intercept form, so I'm going to start at the y-intercept of 2. And the slope is -1. So I'm going to make a nice accurate borderline, and then before I connect the dots, I go look and I see that that inequality symbol is an open inequality symbol, so I have to connect this with a dotted line. And now, lucky for me again, that point 0, 0 is not on the line, so I can go ahead and test it. So I'm going to test 0, 0 for the blue line. So for the blue line, I have to compare the y value. Is it less than the opposite of your x value plus 2? So in my case, they're both 0. So that simplifies to 0 being less than 2. And that's definitely true. So again, rather than shading directly on my work, what I'm going to do is I really would have shaded below. Right? 0, 0 is below that line, so I would have shaded on this side of the line. So an easier way to show your final answer then would be only shading the answer. So where did I shade both of them? Where am I above the red line, but below the blue line. And that's this region right here. Any point that I choose in this area, it's above the red line and below this blue line. So just an alternate way of showing your answer, but again, our final answer is always a very clear shaded region that satisfies both inequalities.